Welcome to my mathematics video series as we look at algebra. So today I'm going to give you some concepts that you need to remember in your paper 1, ECZ, exams. So under algebra, you're going to look at what we are calling as being factorization. Yeah, so you're also going to look at what we call as being simplification. You can also look at what we are calling as being expansion. Yeah, so you're going to look at expansion. So these are some of the concepts that you need to remember in both your paper 1 and paper 2. But today, I'll focus my attention on what we are calling as being factorization. Now, when it comes to factorization, there are so many ways of factorizing. For example, you can factorize by by common factors, so you can factorize by common factors too. You can actually factorize by what we are calling as being using the difference. So you can also use the difference of two squares. It is also possible for you to factorize by using what we are calling as being when you are dealing with trinomials, where you use what we call the PSF factor, product, sum, and factor. So you can actually get to factorize using that method. I'll quickly show you on how you can go about factorizing some of them. For example, when you're dealing with what we are calling as being common factors, when you're factorizing using common factors, for example, if you have got 2x minus 10 in this case, so you can look at either for a number or a letter. In this case, we call it a variable that, if at all it is common or found on both sides of the terms that you have been given. So this side, I've got 2x minus 10. So I can see there's x, but there's no x there. So x is not common, but there's a 2 here. 2 can go into 10. So meaning that 2 is a common factor. So therefore, I remove the 2 outside. So the moment you remove the 2 outside, the number you remove, whatever you remove outside, it's like you start dividing throughout so that you can know what remains. So 2 into 2x, remember, if you have got 2 multiplied by x, you are dividing by 2. This 2, 1, 2, and that one will cancel, so you remain with x. So I'll remain with x there. Minus 2 into 5 is simply a 5. So that is what we mean to say we are factorizing. It's actually the reverse of expansion. That is what we call as being factorization. Now, when you factorize, you are not changing anything. When you say 2 times x, you should be able to get to x. 2 times 5, you should be able to get 10. You are basically changing nothing. Suppose I gave you something like 3x. I gave you to say 3x minus maybe 48 there. Can we factorize, that one? Of course, it is possible for us to factorize. Let me say, xy. So when I look at that, 3 is actually common because 3 can go into 48. What else is common? I also have x there. So it is going to be 3x squared, minus. So remember, you can have, sorry, not 3x squared, but we are just going to have 3x because that is what is common. So this, you pull it out. So it's like you divide by 3x on both sides. So when I divide 3x, this 3 and that 3 will cancel, the x and the x will cancel. So therefore, I'll remain with the 1. 3 there, 1, 3 into 48, 3 into 4 is 1, remainder 1. 3 into 18 is a 6. This x and that x will cancel, so I'll remain with y. So it simply means I've actually, factorized. So when you factorize like that, we're simply using common factors. So it is possible you can factorize by using common factors. The other way that I didn't talk about that I'm going to teach you about is that you can also factorize by grouping. So you can also factorize by grouping terms, so where you just group terms. So I'll basically show you how to do that. But my focus in this video is looking at factorization using difference of two squares. So you can use what we are calling as being factorized by using difference of two squares. Now, how do you go about by using difference of two squares? Well, imagine you have got a number, a letter, a raised to the power 2 minus b raised to the power 2. Well, if at all the variables that you're dealing with have both been raised to the power 2, you can factorize that. This can be factorized where in one bracket you are going to have a positive and in the other bracket you are going to have a negative. But of course, how do you go about that? Well, it simply means a squared minus b squared can be written as you get your a there, 1a, then you say plus, you get 1b from there, close them in the bracket, open again, you get the a minus, in this case, the b that you have there. So this is a rule that we are going to be using, which we simply call as being difference of two squares. So remember, whatever you have should be raised to the power, should be raised to the power 2 in order for you to apply the difference of two squares. Now we are going to be dealing with variables. We are also going to be dealing with numbers. Let me quickly give you what we call square numbers, because you'll be using square numbers. So a square number is a number that can be written in the form n raised to the power 2. So any number that can be written in the form n raised to the power 2, we call it as being a square number. For example, I can write 1 raised to the power 2, 2 raised to the power 2, 3 raised to the power 2, 4 raised to the power 2, 5 raised to the power 2, 6 raised to the power 2, 7 raised to the power 2, 8 raised to the power 2, 9 raised to the power 2, 10 raised to the power 2. You can go on, so on and so forth. Now, what is 1 raised to the power 2? It is 1. What is 2 raised to the power 2? 4. 3 raised to the power 2, that is a 9. 4 raised to the power 2, that is a 16. 5 raised to the power 2 is a 25. 6 raised to the power 2, 36. 7 raised to the power 2, 49. 8 raised to the power 2, that is 64. 9 raised to the power 2, that's 81. 10 raised to the power 2, that is 100. So all these numbers that I've written here at the bottom, these numbers are what we simply call as being a square number. Why? Because these numbers at the bottom here that I have, these numbers at the bottom here can be written as n raised to the power 2. 1 can be written as 1 raised to the power 2. 4 can be written as 2 raised to the power 2. 9 can be written 3 raised to the power 2, and so on and so forth. And that is why we call them as being square numbers. So as we use our difference of two squares, factorizing using difference of two squares, we are going to be using some of these square numbers. Please, you need to remember. Let me just show you a few examples on how you can go about that. I'll flip to the other side and try to look at factorization. For example, the questions there say factorize completely. So they say factorize completely. So how do I factorize completely? So they have given us in the first part there 332x raised to the power 2 minus 50. So when they tell you to factorize completely, first of all, try to look at what is common. Is there anything that is common? Yeah, of course, there's something that is common. Remember, 2 can go into 32, that's 16 times, and 2 can go into 50, that is 25. Remember, this is in paper 1, so no need of using a calculator. So 2 can go there, which is common. So I'll put the 2 outside. I'll open the bracket. Remember what I said, what you remove outside, you divide it throughout there so that you can know what remains. So 2 into 32 is 16x squared. And of course, 2 into 50, that would be minus 25. Now, you might be tempted to end there. Remember, we are using difference of two squares. So ask yourself, can what is inside of the bracket be expressed as a square number? Can you express it as a square number where you write it as n raised to the power 2? Yes, it is possible. 16 is a square number, therefore it will be 2. Open 16 can be written as 4 raised to the power 2. That x is already raised to the power 2. 25 is a square number which can be written as 5 raised to the power 2. Therefore, what is inside the bracket now, we can apply the difference of two squares in this case. So remember, when there's a minus, you can use the difference of two squares. So it will be 2, open bracket here. I'll simply say I'll pick up a 4 and I'll pick up the x because they are both squared. Minus there, I'll pick up a 5, close the bracket. Open the bracket, you repeat that, 4x, but this time plus a 5. So it simply means we have factorized completely. So that is the way you can go about that. Please, what is important, pay attention to the square numbers. That is what you're going to be dealing with mostly. Let's look at the B part there again. Let's look at the B part there again. So the B part there says that factorize completely 18 minus 2x raised to the power 2. Again, start with what is common. What is common there? All right, what is common is actually a 2. You're right about that. So the 2 will be outside. So I'll divide 2 throughout so that I can know what will remain. 2 into 18 is a 9 minus 2 into that. This 2 and that 2 cancel. I'll remain with x raised to the power 2. Now, of course, don't be tempted to remain there. Remember, this is x raised to the power 2 and 9 is a square number. We can go further and simply say 9 can be written as 3 raised to the power 2 minus x raised to the power 2. Therefore, it will be 2. You pick up in this, using a difference of 2 squares, you work out what is inside of the square root. So I'll pick up a 3 there, minus, I'll pick up x there, then in the other bracket it will be 3 plus x again. It simply means you have factorized completely. Of course, someone may say, okay, you said if we have, for example, a raised to the power 2 and b raised to the power 2, you said one of the brackets should be positive, and the other one you should have a negative. So it doesn't matter, you can start with either a negative or a positive. It is still the same thing. Don't always, you can start with a negative in the first bracket and you have a positive in the second bracket. It's okay, that will still work out. We are still referring to that as being difference of 2 squares. Let's move on to the C part so that we can assist you on how to go about that. So the C part there again, simply says 5x raised to the power 2 minus 5. Again, what is common? That's the first thing that you need to ask yourself. What is common is a 5, so therefore I'll put a 5 outside. So write the 5 outside of the brackets, as you call them, parentheses. Then I'll divide what is common on both sides. There when I divide, I'll remain with x squared. There when I divide, I'll remain with 1. People would be tempted to remain there, but remember that 1 is a square number. Because this one is already a square, you can write that one as a square number, which can be written as 5x raised to the power 2 minus 1 raised to the power 2, because 1 is always a square number. So we can now work out that further by applying difference of 2 squares, what is in the bracket. So it will be 5, it will be x plus 1, and the other bracket x minus 1. It simply means that we have factorized it completely. So that is what they mean when they talk about that. Right, I hope you have gotten the concept. Let's do the D part there. The D part there says, a, so it actually says that, ax squared y minus ax squared y minus 4ay squared. Please pick out what is common. What is common there? Of course, I've got a, it is common, and I've got y, which is also common. So therefore, a and y will be outside. I'll write them outside of the parentheses. So remember, open the bracket. What you have factorized out, you need to divide it ay, even that side ay, so that you know what you are remaining with. So this a and that a will cancel, the y and the y will cancel, I'll remain with x squared minus. The a and the a will cancel. Here, if you notice there, when you factorized, okay, so sorry for that. I believe in the question, but what was true is that the one, this had actually a 3, it was raised to the power 3, so therefore there it is supposed to be raised to the power 3, right? So when you still factorize your 1, you're going to remain with 4y raised to the power 2, because we are using difference of 2 squares. So now if you notice what is there, because that 4 is a square number, and this one is a square, has been raised to the power 2, that one has been raised to the power 2. Therefore, you can say ay, this will be x squared minus 4 can be written as 2 raised to the power 2, y raised to the power 2. Now, when all of them have been raised to the power 2, you can apply the difference of 2 squares with what is inside the bracket. So therefore, it will be ay, open brackets, there will pick up x, plus there will pick up a 2 and a y, and again I'll repeat that, but this time with a negative. So it simply means we have factorized that. That's how simple you can actually do it in your paper 1 when they give you such expressions. All right, let's conclude by looking at the E part there. The E part, looks complicated. It says x squared over 4y raised to the power 2 minus 1 over 9. Well, a person might actually be tempted and say, well, this is very complicated. It's actually not complicated. There, of course, you can say what is common. There's nothing that is common, but remember 4 is a square number, 1 is a square number, 9 is a square number. That is very important. So we can rewrite and say x squared over that 4 can be written as 2 raised to the power 2, then y raised to the power 2 minus that 1 can be written as 1 raised to the power 2. That 9 can be written as 3 raised to the power 2. So you can see all of them have been raised to the power 2. And that's the idea of using difference of two squares. If you are using the difference of two squares, they should all be raised to the power 2. So now we can apply the difference of two squares. Remember, if you have got x squared minus y squared, one of the bracket will be x plus y, then the other one will be x minus y. So get the x and get the y, but in the first bracket you can put up a positive, in the other one a negative. So that's the rule we are using, difference of two squares. So here I'll get just x, there I'll say over, I'll get a 2, there I'll just get 1y, minus there I'll just get 1 there I'll just get 1 3, and close it in bracket. Then in the other bracket I'll repeat the same, x over 2y minus this time 1 over 3. Then it simply means you have factorized. So this is what they wanted you, to do. So you can do a whole lot of these questions. They can simply ask you, to factorize. It is possible that you can actually factorize, and don't give up. It is very easy. So in my next one, I'm going to look at, factorization using what we are calling as being, grouping terms. Yeah, and I'll also talk about factorization by using trinomials, using the product sum and factor. So that's what I'll look at. Thank you so much. Watch out for my next video.